So I'm just going to run through the 3.3 lecture for those of you that are missing. 3.3, we talked about some properties of logarithms, or continue the properties of logarithms. And one of the things is evaluating logs with other bases. So remember that 10 and E are special and they get their own button on a calculator next to the number 7 and the number 4. Now we can talk about a base of change formula. So if it's some base that is not on the calculator, notice where the base goes. So if A, whatever base it is not on the calculator, you just put that number on the bottom and the X goes there. And what it's saying is log base B, you can do a log base, change of base formula, with any base you want. So let's go to this first example. They're talking about a log base 2. And the first day of the lecture, we talked about how 2 cubed is equal to 8. 2 to the 4th is equal to 16. So that number fits somewhere in between there, so it must be some sort of decimal. So what I would do is write maybe log base 10, log base 10. Those two logarithms now have to be the same base. Put the 12 on top and the 2 on the bottom. Or if you want, a little bit lazy, you just write ln. Remember that's ln is base E. So you do the ln of 12 and the ln of 2. So if I go to my calculator, you can clearly see that they turn out to be the same thing. So if I do clear that out, if I do the log of 12, you have to make sure you close your parentheses before you divide by the log of the base, so base 2. Now these are both log base 10s of 12 of 2, and I get that decimal. Or I can hit ln of 12 divided by the ln of 2. So it doesn't matter which button you use on the calculator, notice you get the same decimal. So if you want to try this one, pause that video and try log base 3 of 17, see what you get, and then I will do the problem. So bringing it back now, I tend to always just write ln of 17, ln of 3. So again, when you go to your calculator, type in ln of 17 divided by ln of 3, and then you can write down your decimal. So again, it doesn't matter, but ln of 17 divided by ln of 3, 2.5789. Okay, so the change of base formula is going to help you. Then we also have some more properties. You're going to do a product property, quotient property, property power, power property. So it's, if you're if you're multiplying, that's called a product. That's multiplication. Then it splits up into two different logarithms. If you're doing a quotient, dividing, you split them up into two logarithms, but this time you subtract. The same thing can be said with the natural log base. So right now this is called expanding it, writing it in terms of sums or differences. So sums or differences. So on this first one, they're asking us to expand it. I use the log base 4, so I write log base 4 of the 5 plus log base 4 of the x cubed plus the log base 4 of the y. So everything in here, this is all being multiplied. So I split it up into all the sums. Now, this one, log base 4 of 5, 4 to a power is 5, that's not a nice number, so I'm going to leave it there. The last property was this power property, and all it's telling you is that if you're taking the logarithm of an exponential, we can go ahead and bring that exponent down. So I'm just going to bring the 3 down in front. So the final answer would be log base 4 of 5 plus 3 log base 4 of x. All I did is bring its exponent down in front plus log base 4 of y. What if I go the other direction? What they call condensing, or write as a single logarithm. So if we write this as a single logarithm, I would First, double check. Notice that it's all log base 10. So I could put the 1/3 back up top. Oops, a little too far. 1/3 back on top of that x. And raising something to the 1/3 power is really a cube root. So this is really the cube root of x now. And then when I put the 5 back up on that parentheses, I have plus log of x minus 3 to the 5th power. But because I'm adding these two things together, I can write one logarithm and then just write the two things next to each other. So I can do the cube root of x with the parentheses x minus 3 to the 5th. Now to make sure somebody's reading it properly, you might even go as far to say put this all inside that one logarithm. And so that would be done. So again, we're going to have some DIYs here, so I want you to go ahead and pause the video, fill them out, and then I'm going to help you do them. Okay, so hopefully you paused the video and you've done all these problems. This first one, I would split up into two parts. We're going to do natural log of the top thing. Oops, 3x minus 5. But because I'm dividing, it's minus the ln of 7. Now we can go back to the square root. Square roots, remember, are the same as something to the 1/2 power. So this is really, I could bring the 1/2 in front and just do the ln of 3x minus 5 minus the ln of 7. And then looking at it, there's nothing else to simplify. This is a product of two things, so I can go logarithm of 2 plus the logarithm of x to the 4th. So again, we can bring the 4 down in front. And remember, these are really base 10s. If you want to write the 10 in there, it's not a big deal. But there's nothing we can do to simplify. Log base 10 of 2 plus 4 times the logarithm of x. And again, that would be base 10. Don't have to write the base 10, you can if you want. On this one, there's a negative out in front of the logarithm. So remember right here, that's actually a nice number. 10 to what power would give you 1 over 100? 10 to what power would give you 1 over 100? So that thing actually means negative 2. So we have the negative of negative 2, and that simply simplifies to give you 2. So they're not always something that you're going to write a property, just kind of watch. If you rewrote everything, you might write it by rule, which would be log base 10 of 1 over 100. But remember that negative could go back on top as an exponent. So now this is log base 10. A negative exponent means flip to the reciprocal. So what do you get? You get 2 that way also. Okay, a couple more. You should have done these. Again, you're supposed to pause the video and do them. So this one is a natural logarithm here and a natural log, so I can combine them into one. So I'm going to put the 2 back up in the exponent. This time it's subtraction. So I'm going to put the first one on top, and you only do one ln. So ln of what? Anytime you're subtracting, you're going to have some sort of rational expression or what looks like a fraction. So the x plus 2 squared is what goes on top, and since this one is being subtracted, its x goes on the bottom. That's it. No simplifying to be done there either. All right, this last one that you might have done, again, log base 2, log base 2. So I'm going to go 1 log base 2 of all the stuff. So I'm going to put a 48 on top and a 3 on the bottom. Now this one we have to do a little more simplifying because log base 2, 48 divided by 3 is 16, and then 2 to a power gives you 16. 2 times 2 times 2 times 2 is 16. So how many 2's did I line up? I lined up 4, so this answer is 4. So hopefully you did those problems, and now you look at it. So now we're going to look at some DIYs. So again, you want to pause the video, go through these, see if you can find any errors. So somebody has applied these properties, see if you can find any of the errors, and then I'll come back and do the problems for you. Oops. So hopefully you're back now and we're ready to go ahead and find some of the errors. I'm just getting rid of some of this. But somebody applied the properties, they've made some mistakes. Here we go. So somebody did a logarithm, this is base 10, and this is base 10. And they said log base x minus log base y is equal to log of x over log y. And they're close. You definitely are going to end up with x over y, but you don't put a logarithm on top and bottom. So if you go back to where the property is written, several logarithms combined into one. So you only want one logarithm. That's the one that's correct. What about log base 2 of 5? Base 2 does not have its own button on the calculator, so you should apply the base change. And what we want to remember is if you do log over log, the base number always goes on the bottom. So if you're in class, I would say that over and over. Its base always goes on the bottom, and the 5 goes on top. And then the next one, log base 3 of 7. It looks like somebody tried to apply something. So again, that's not correct. We don't want that. I could, however, write it as a base change again. Log base 7 divided log base 3. You could also do ln of 7 over ln of 3. You could ask yourself, 3 to some power is 7. Maybe you wrote it as an exponential. But what they wrote, the 7/3, they got the base on the bottom, but I'm guessing they wanted to do a base change, and they got that base change wrong. So then this last one,